You're welcome. Good morning. How are you today? Good morning. Welcome to today's class. So we're going to look at temperature measurement. Okay. So before we go into that, there are some things we need to note, which is heat and temperature. Before we talk about temperature and heat measurement, there must be application of heat, okay, that causes a temperature change, right? So you should know what is heat and temperature and difference between them, okay? Then before we go into temperature and different scales which in measuring what temperature. All right, so let's wait for a little while for our students to come online so that we can proceed. All right. Veronica, you're welcome. How are you today? Hello, good morning. If you're online, say hi. Let's know so we can proceed. What's so get you? This is SS1. SS2 rather. Once you should be in SS1, right? Once is in SS1. SS1B precisely. So our class for you today will be by one and by two. Okay. All right, Veronica, you're welcome. Fubara, you're welcome. All right, once you can still join us, you're still learning. You can still join us, it's not bad. Okay, so we can proceed. I have just a minute for us to proceed. Let's see if some of you will come online so that we can start. All right, so let us start. All right, put it down. Fubara, can you see it now? Can you see it now? At Fubara, yellow. Yellow, can you see it now? Okay. All right, so put it down. Let's proceed. All right, are we done writing? Let's start explanation. Clifford, you are here. All right. Are we done writing? Let's explain. Okay. So let me explain. Temperature measurement. All right. So under it, before we go into the topic, we need to know what is heat and what temperature. Certainly, it can help you to know the difference between both of them. All right. So we can go to heat. Heat is a measure of the total internal energy of a body. It is a form of energy due to temperature what? Difference. So when you apply heat to a body, it causes temperature what? Difference. Now, what is this heat? Heat is the total internal energy because the energy is coming from where? From inside of that particular substance. Do we understand? So energy that is coming from a particular substance is said to be what? Heat. So if your temperature is high, you are going to start what? Brings about what? Heat. So because the energy is coming from where? Inside of the body, so it's classified as heat. All right, and it is due to temperature what? Difference. When there is a temperature difference between the body for a certain time can bring about heat. Now, the unit of heat is what? Joule. Heat is measured in what? In joules. Now, heat is calculated with a calorimeter. Heat is calculated with a calorimeter. How do I mean? You cannot say it is measured because you're going to use the calorimeter to measure the amount of heat in a particular body. Is that clear? All right, so let's go to temperature. Temperature is the degree of hotness or coldness of the body. It is a measure of the average kinetic energy of the molecules of the body. Now, that instrument or the rate in which you check the coldness or hotness of a particular substance or body says to be what? Temperature. Now it is measured in Kelvin and we use an instrument called what? Thermometer to measure the temperature of what? Of a body. Is that clear? Even though we have different types of temperature and their uses, but you just have to know that we use thermometer to measure the temperature of a body. Is that clear? All right. All right. Are we done? Fubara Clifford, are we done? Veronica, are you still here? All right. All right, please copy fast. Let's proceed. All right, so let me explain. All right, fixed temperature measurement. I've explained heat and temperature. Now, the lesson is for us to look at the fixed temperature point of a thermometer. I told you earlier that we use thermometer to measure what? Temperature. Thermometer has two reference temperature fixed points. A certain thermometer has two reference fixed points, has two reference temperature fixed points, okay? They are called the upper fixed point and the lower fixed point. So if this happens to be a thermometer, if this is a thermometer, it must have what? Upper fixed point and what? Lower fixed point. Is that clear? If this is a thermometer, it must have what? Upper fixed point and lower fixed point. So this should be upper, while this is what? Lower. Do you understand? Because the thermometer is a straight apparatus. Now this is upper, while this is what? Lower. That's what it's trying to say. All right, the upper fixed point is the temperature of steam from pure water boiling at standard atmospheric pressure of 760 millimeter of mercury. Now, what is it trying to say? That the upper fixed point is the temperature of what? Steam. So what do you mean by steam? Before water will boil and get up to steam, steam means it evaporates. So it means that it has gotten to a fixed temperature point, and the temperature of boiling water is 100 degree what? Celsius. Okay, so whenever the water boils to this 100 degrees Celsius, it's classified to be the upper fixed point, right? So the upper fixed point is the temperature of steam from pure water boiling at standard atmospheric pressure of 760 millimeter of mercury. Do you understand? So that is the upper fixed point. So let's look into the lower fixed point. Tenny Goma, Clifford, Fubara, are we done? Veronica, are we done? We can proceed. I want to clean the board. All right, put it down. All right, put it down first. Then you go, ma. Clifford, Fubara, are we there? All right, are we done? Okay. Okay, so let's go to the lower fixed point. I've explained upper fixed point as the temperature of what? Steam from pure water, right? So before the water will boil up to the vapor level or to steam level, it has gotten up to the upper fixed point, okay? Upper fixed temperature point, which is the 100 degrees Celsius. Now, the lower fixed point is the temperature of pure melting ice at the standard atmospheric pressure of 760 millimeter of mercury. Is that clear? Pure melting ice. Before ice will melt, or okay, let me say, bring out your ice from your freezer. It has its temperature as well as 0 degrees Celsius. And even if the ice melting, it's still the same temperature as 0 degrees Celsius because the water is still cold. Do you understand? All right, so the difference in temperature between the two temperature points is called the fundamental interval of a thermometer. How do I mean? We have the upper fixed point and we have the lower fixed point. So the difference between the upper fixed point and the lower fixed point, it is said to be the fundamental interval. I'm going to explain that further. Now, there are three types of scale in current use. We have three types of scales. They are the Celsius scale, the Kelvin scale, and the what? Fahrenheit scale. So the three types of scale that we use right now is said to be the Celsius scale, the Kelvin scale, and the what? very high skill. So I'm going to be sketching that and explaining to you how you can use it to solve problem, and certainly how you can convert from this skill to another what skill. All right. All right. Are we done? Veronica, are we done? Fubara, Teni Goma, are we done? Please don't forget, go to Facebook and TikTok and follow my page, okay? It's the same name, Justice Science Academy. Don't forget, go to TikTok and Facebook and follow my page. All right. Okay, Fubara, you are done. Now let's proceed. All right. Now, you can put it out. Let me explain. All right. Farika, you're just joining us for the first time. Have you subscribed to this channel? All right. Put it down. Let me explain. Have a few seconds to do that. Okay, so these are the three types of scale that we use right now. The first one is the Celsius scale, followed by the Kelvin scale and the Fahrenheit scale. There is one thing you must take note in these different scales. What's important there is their upper fixed point and the lower fixed point. I said earlier that the upper fixed point is the temperature of steam from pure water, right? Boiling at a standard atmospheric pressure of 760 millimeters of mercury. Now, the upper fixed point for this Celsius scale is 100 degrees Celsius, and the lower fixed point is 0 degrees Celsius. Now, for this Kelvin scale, the upper fixed point is 373 Kelvin, while the lower fixed point is 273 what? Kelvin. Is that clear? Now, for this Fahrenheit scale, the upper fixed point is 212 degree Fahrenheit, and the lower fixed point is 22 Fahrenheit. Is that okay? All right. So, what is the fundamental interval? Because I told you that the fundamental interval is the difference between the upper fixed point and the lower fixed point. So simply say that the fundamental interval for this Celsius scale is 100 minus 0, which is what? 100, right? The fundamental interval for this scale is equals to 373 minus 273, going to give us what? 100, okay? Now the fundamental interval for this Fahrenheit scale, 212 minus 32 is going to give us what? 180. Is that clear? So these are the fundamental interval for this type of what? Type of thermometers. So, but what is important for you to note is for you to know their upper fixed point and what? Lower fixed point for each of them. Because we're going to be comparing from this scale to another what? Scale. We're going to be converting from a scale to another. So you should know their upper fixed point and their what? Lower fixed point. Is that clear? Alright. Are we cleared? Then you go, ma. Veronica, Joanne, Fubara, Farika, are we cleared? Do you understand? Please, I need your response so I can be working with that. All right. All right. So what we have, we're looking at how to convert from Celsius to what? Kelvin. If you are given a temperature and it is given in degrees Celsius and you are expected to convert it to Kelvin, what are you going to do? Simply by adding 273 to that value given to you, whatever thing you have is now what? Converted to Kelvin. Because this 73 is said to be the absolute temperature. Is that clear? Alright, so for example, if if I have 27 degrees Celsius and I'm asked to convert it to what? To Kelvin. I'm going to say this is 27 degrees Celsius plus 27 what? 3 degrees Celsius. Is that okay? Then whatever thing I have, my answer will be in what? Kelvin. And the answer to this question is 300 what? Kelvin. Is that clear? All right, so I want you to try this one. 125 degrees Celsius. I want you to convert it to Kelvin and drop your answer right now. Yes, I'm waiting for your answers. All right, so let's work it out. Everybody's getting 398 kV. So it's just like saying 125 degrees C plus 273 degrees C. And my answer becomes 398 what? Kelvin. Is that clear? All right, so let's proceed. Asakwe, please, thank you so much for coming. I really appreciate. Please take down what you have on the board. Let's solve. Veronica, can you see it now? Is it clear now, Veronica? Veronica, can you see it now? It's very clear now. Is it okay? As Veronica, can you see it now? It's clearer now. All right. But I can't see the right side of the wall. Check. It's very clear. I can see it from my end. All right, so let's solve this problem. A thermometer with an arbitrary scale x. It means that this thermometer, each scale is called what? X. Remember, in Celsius we have degree Celsius, but this one is what? X. So degree X, okay? Of equal divisions, registers minus 30 degrees Celsius, minus 30 degrees X at the ice point and plus 90 degree X at the steam point. Calculate the Celsius temperature corresponding to 60 degree X. Now, if you have this type of question, one thing that will come to your mind, this is a thermometer, okay? But its scale is what? X. It is called X thermometer. Do you understand? And a particular thermometer, which is a single thermometer, must have the upper fixed point and the lower fixed point. All right, so we're going to use a diagram to illustrate. This is this thermometer that registers what? X. Okay. Now it has the upper fixed point to be what? It registers minus 30 degrees Celsius to the ice point, which is the lower fixed point. So I'm now saying here is what? 30 degree X. Okay? And also registers plus 90 degree X at the steam point. So here is what? Plus 90 degree X. Okay? Now calculate the Celsius temperature corresponding to 60 degree X. I'm going to draw the Celsius temperature. This is degree what? Celsius, right? Corresponding to 60 degree X. Now, the upper fixed point of this scale, let me start again so I can shift this diagram here. Sorry. All right. I will start by sketching this particular thermometer, which is X. This is a thermometer, right? It is called what? Measured in degree what? X. And it registers minus 30 degree X at the ice point. Ice point is the lower fixed point, which is the down part. So I will have minus 30 degree X. Is that clear? And also plus 90 degree X at the steam point. So this becomes plus 90 degree X. All right, so Celsius temperature. Now we are comparing this thermometer that registers degree X to a Celsius scale. Do you understand? So I'm going to draw a Celsius scale. And we already know the upper fixed point and the lower fixed point of a Celsius scale. So let's just do a sketch. We have this one is degrees Celsius. The upper fixed point, remember, is constant, which is 100 degrees Celsius, while the lower fixed point is 0 degrees Celsius. Is that clear? All right, so calculate the Celsius temperature corresponding to 60 degree X. Now, they've given us the fundamental interval of this thermometer at 60 degree X. 60 degree X. Okay? Now, looking for this equivalent on this Celsius scale. So we are looking for this. I can call it X. Do you understand what I just explained? Now, I have to draw this particular scale and insert the upper fixed point and the lower fixed point given in that question. Then since you're comparing it with Celsius scale, I'm going to draw Celsius scale. And they now give us the fundamental interval of this thermometer. Now I have to write it here as 60 degree X. Now I am looking for its equivalent on the Celsius scale. Am I cleared? All right. Please, do we understand before I proceed with the solving? Veronica, Fubara, do we understand? Tell you, Goma. All right. The formula for this is the fundamental interval minus the lower fixed point. Remember, the middle is fundamental interval. Here is the lower fixed point. Here is the upper fixed point. So let's go. Fundamental interval minus the lower fixed point, right? Divided by upper fixed point minus lower fixed point. Is that clear? Let me do again. The formula is the fundamental interval minus what? The lower fixed point divided by the upper fixed point minus what? Lower fixed point. We are going to do it for these two scales. We equate them together and find the unknown. Is that clear? The fundamental interval minus what? The lower fixed point divided by the upper fixed point minus what? The lower fixed point. So let's go. We are going to start with this one. Is that clear? All right, so we go. The fundamental interval here is 60, so I will say 60 minus the lower fixed point is minus 30. I'll put in bracket minus 30. Is that clear? And divided by the upper fixed point is 90. 90 minus the lower fixed point is what? Minus 30. I'll put in bracket minus 30. Is that clear? Now this is equals to the fundamental interval here is what? X. I'll say this is x minus the lower fixed point is 0. All right. Now divided by the upper fixed point here is what? 100 minus the lower fixed point is what? 0. Is that clear? All right. So let's work it out. This is 60 minus times minus is what? Plus. 60 plus 30. Okay. Now we have this 90 minus times minus is plus. We have this, right? Now this is equals to what? X minus 0 is x. 100 minus 0 is what? 100, right? Now for us to summarize, I'm going to add this. 60 plus 30 is going to give me 90 over 90 plus 30 is going to give me 120. Is that clear? Now it is equal to x over what? 100. Because we're looking for the value of x, which is the temperature on this Celsius scale, we're going to say cross what? Multiply. Now we have 120x is equals to 90 times 100 is what? 9,000. Now we want to find the value of x by dividing by the coefficient of what? S, which happens to be 120. Then we have 120. We cancel this. So my x is equals to 9,000 over 120. By the time you divide it, with the help of your calculator, let's see what we have. We have 9,000 divided by 120. The answer is what? 75 degrees Celsius. You know why you have 75 degrees Celsius? Because you're looking for the temperature on this scale. Is that clear? All right, put it down. If you have question, you can ask. Please put it down. If you have question, you can ask. All right, understood. Okay. So let's do another example. All right, put it down. Let's solve. Thank you, sir, for coming. Nakuzi Onyeka. God bless you. Really appreciate. Please copy fast. Let's proceed. All right, let's solve. The question says a thermometer has its stem marked in millimeters instead of degrees Celsius. Did you get it down? A thermometer has its stem marked in millimeters instead of what degrees Celsius. Okay. So instead of them to mark it in degrees Celsius, they mark it in what? Millimeters. All right. The lower fixed point is 30 millimeters and the upper fixed point is 180 millimeters. Calculate the temperature in Celsius when the thermometer reads 45 millimeters. It's still just the same way we solved the previous one. What we are going to do is to sketch our thermometer in millimeters and also compare with that of what degrees Celsius and find the unknown. All right, so let's sketch. This one is 10 in millimeters. All right. The lower fixed point is 30 millimeters. The down part is lower, while this one is upper. So this is 30 millimeters. And the upper fixed point is 180 millimeters. Calculate the temperature in Celsius. So let's go to Celsius scale. This is what? Degrees Celsius. Now we already know that in degrees Celsius, the upper fixed point is what? 100 degrees Celsius and the lower fixed point is 0. Okay, calculate the temperature in Celsius corresponding or when the thermometer reads 45 millimeters. Now they're giving us the fundamental interval of this to be 45 millimeters. So how do we get this? Call it x. Is that clear? So the same formula we applied in the first one is applicable to all questions that is like this. What are we going to do? Fundamental interval, which is the middle minus the lower fixed point, divided by what? Upper fixed point minus what? The lower fixed point. So going by that, we say that 45, which is fundamental interval, minus 30, now is divided by, 180 minus 30. Is that clear? The fundamental interval minus the lower fixed point is divided by the upper fixed point minus what? Lower fixed point. That is what I have. Then I will equate it to this one. Is equals to the fundamental interval here is 0 minus the lower fixed point is 0. Then divided by the upper fixed point is 100 minus what? The lower fixed point is what? 0. Is that clear? Okay. Now let's subtract to see what we'll have. 45 minus 30 is going to give us 15 divided by 180 minus 30 is going to give us what? 150. Is that clear? Now this is equals to x minus 0 is equals to what? X over 100 minus 0 is equals to what? 100, right? What are we going to do? Say cross multiply. That is 150x, right? X times 150 is 150x is equals to 15 times 100 is what? 1500. Now, because we are looking for the value of x, I'm going to divide both sides by the coefficient of what? X, which is 150. So x is equals to 1500 over what? 150, right? So by the time you divide, you're going to have 10 degrees Celsius. Is that clear? Do you understand? All right, put it down. All right, put it down as Fubara, Clifford, Veronica. Do you understand? Osage, you are here. All right. All right, put it down. Let's solve more examples. Osage, don't worry, you can watch it after now, okay? Let me just go to the next one. The next one, so you'll be able to understand better. We'll go to the next example. You can watch the video after now because it will be online. All right, put it down. Let's solve. Accurately calibrated. accurately calibrated. Please, if you are just joining us, give it a thumbs up, okay? Are we done writing? Are we done? All right, let's solve. A thermometer which was not accurately calibrated. You must understand the English and what they mean by that. A thermometer which was not accurately calibrated indicates minus 0.5 degrees Celsius at the lower fixed point and 106 degrees Celsius at the upper fixed point. Let me go again. A thermometer which was not accurately calibrated. That means there was an error when they are calibrating this thermometer. So this thermometer can be classified as a faulty thermometer. All right, it indicates minus 0.5 degree Celsius at the lower fixed point and 106 degrees Celsius at the upper fixed point. What temperature does the thermometer registers? This thermometer we asking now. What temperature does this thermometer that is what registers when the true thermometer temperature is what? 60 degrees Celsius. This true means the one that is correct, that is not faulty. Now, what does this faulty thermometer registers when the correct one reads 60 degrees Celsius? Now, I'm going to sketch a diagram to compare the faulty Celsius scale and the correct Celsius scale. All right. This is what? Faulty. Why this is what? Correct. They are all Celsius scale. Now, this one that is faulty registers minus 0.5 degrees Celsius, the lower fixed point. So here is what? Minus 0.5 degrees C, right? Why it registers 106 degrees Celsius, the upper fixed point. And for the correct one, you already know that the upper fixed point of a Celsius scale is 100 degrees Celsius, and lower fixed point is what? 0 degrees Celsius. Now, what does this thermometer register? What does this faulty one register? When the true temperature is what? 60 degrees Celsius. So when this one that is correct, 60 degrees Celsius, what will this one register? It's as simple as that. And we are going to use our formula to solve. If you remember the formula, what's the formula? The formula is fundamental interval minus 1, the lower fixed point, divided by the upper fixed point minus the lower fixed point. So what's my fundamental interval here? X. I will say x minus, because there is a negative sign, I'll put it in brackets, minus 0.5 divided by 106 minus bracket minus 0.5. Is that clear? All right. Now it's equals to, what do we have here? 60 minus 0. We have 60 minus 0 divided by what? 100 minus 0. 100 minus 0. Is that clear? Now what we're going to do next is to open the bracket. So we have x is plus 0.5 divided by, right? 106 minus times minus is plus 0.5. Now it is equals to 60 minus 0 is what? 60 all over 100 minus 0 is what? 100. Is that clear? Now let's bring it down again. We say this is x plus 0.5 divided by 605, 106, sorry, plus 0.5 is going to give us what? 106.5, right? Now it is equals to 60 minus 100. Is that clear? Because you're looking for the x, which is the unknown temperature, let's do cross multiply. Navigate again. This is 100 bracket x plus 0.5, right? Now it is equals to 106.5 multiplied by what? 60. Now let's just open the bracket straight by saying 100 multiplied by x, that is 100x plus 100 times 0.5, that is 50. Yes? Hope I'm not mistaken. 100 multiplied by 0.5, that is 50, okay? Now let's go. 106.5 multiplied by 60, I have 6390, okay? Then I'll take this to this side. 100x is equals to 6390 minus 5, right? 100x is equals to 6340, right? Now if I divide by the coefficient, of x, which is 100, 100 cancel itself and left with what? X. So 6340 divided by 100 is going to give me 63.4 degrees Celsius. Is that clear? Do you understand? So this type of question, we have to look at it and analyze it. And you must not forget that the true temperature is the correct one, because here I'm dealing with Celsius and Celsius scale. But one is faulty while the other one is correct or accurate. So now you can see the difference between them to know that this true temperature becomes the accurate one or the correct one. So you don't mix it up, because if you mix it up by putting this CC here, the question, your answer will be wrong. Hope that is clear. All right. Yellow, so you have a question. Okay, I'm all ears. All right, Fubalayeru. So we are asking, why can't we use, why can't we just use the upper fixed point minus this to get the fundamental interval? No, why we are not going to do it that way is because we are doing comparison. You must compare with the one that is complete. For example, the accurate Celsius scale is complete. So you must compare it with the faulty one to be able to get the difference or the unknown. All the ones we have been solving, we have to compare. We are doing comparison. That is just the way to do it. We are doing comparison, compare it with the correct one, then you find the unknown. Osage Grace, are we going to learn tomorrow? Yes, we are going to learn tomorrow. We are going to learn tomorrow. I'll tell you people the time. It won't be normal time, 11. Are we done? Are we done writing? I'll give you assignment. We are not done. Once our time expires, I will give you assignment and I'll end the class. All right, let's go to the next one. All right, put the question down. Let's solve together. Secondus, what happened? For 2 days, I've not seen you. All right, let's solve. Example 4. The fundamental interval of a Celsius thermometer is 250 millimeters, right? What is the temperature of the mercury level? What is the temperature when the mercury level is 45 millimeters above the ice point? Now, looking at this question is somehow different from what we have been solving, but it's still the same. I'm going to show you the difference or why it is so. The fundamental interval of a thermometer, a Celsius thermometer, is 250 millimeters. 250 millimeters. Now, this one is measured in millimeters, right? And I've given us the fundamental interval. Now, I've told you before that fundamental interval is the difference between the upper fixed point and the what? Lower fixed point. This is upper fixed point and this is lower fixed point, right? Difference between them gives us fundamental interval. So in this question, they've given us the fundamental interval, that is from here to here, to be what? 250 millimeters. What is the temperature when the mercury level 45 millimeters above the ice point? Where is the ice point? Look at the ice point. Okay, so when this thermometer read 45 millimeter above, this read what? 45. Is that okay? And we are comparing it with what? A Celsius scale. With a Celsius scale which has upper fixed point to be 100 and lower fixed point to be what? 0. Now, what are we looking for? We can call it x, right? Now, remember our formula is the fundamental interval minus the lower fixed point, then divided by upper fixed point minus lower fixed point. But since we already have the difference between from here to here is 45, and the difference from here to here is what? 250. So what you are going to say is this. You are going to say 45, because you don't need to find the difference again. It's already calculated in the equation and it was given as 45. Upper and lower is given as 250. So you're going to say 45 over 250 is equals to, what do we have? X minus 0 divided by 100 minus 0, right? Let's go again by saying over 250 is equals to x over 100, right? We say cross multiply 250 times x, that is 250x, is equals to 45 times 100, that is 4,500. So what do we do next? We divide both sides by what? 250. 250, all right? So what do we have? I can say my x, we can divide with our calculator. My x, that is 4,500 divided by 250. My answer is going to be what? 18 degrees what? Celsius. Is that clear? Now, in this type of question, let me do a recap. What we are going to do is to, they've given us the difference, which is 45 meters above the highest point. So from here to here is 45, whereas the difference between this and this is 250. So you don't need to subtract again, it's already given. Just pick the value from here to here, 45, okay? Divided from here to here is what? 250, and that is what we have for this millimeters. Okay, this is millimeter. Why this is what? Degree what? Celsius. Is that clear? Okay, put it down so you can take your classwork. Are we done writing? Secondus, Clifford, Fubara, Tenny Goma, Victoria, Osagwe. Are we done writing? All right, so take your classwork so we can end the class. All right. Put it down and solve, okay? And send me your answers. resistance of 10 ohm. A resistance thermometer has a resistance of 10 ohms at 0 degrees Celsius. All right, so who is done? Send in your answers. We want to end the class now. All right, so let's solve so we can end the class. A resistance thermometer has a resistance of 10 ohms, 0 degrees Celsius, and 70 ohms at 100 degrees Celsius. If it records 55 ohms in a certain medium, calculate the temperature of the medium. Now, in this type of question, what do we do? What we are going to do is to do comparison we did previously. Now, this is a resistance thermometer. We just draw the thermometer. This measures in ohms, right? I have another one which measures in what? Degrees Celsius. Now, this thermometer has a resistance of 10 degrees Celsius, and this 0 degrees Celsius is the lower fixed point. So for this scale, when this is measuring, so it's going to measure 55 watts ohms. Is that okay? All right. And 70 ohms at 100 degrees Celsius. When this is measuring 100 degrees Celsius, this one is what? 70 ohm. Is that okay? Calculate the temperature if it records 55 ohms in a medium. Now, if this one record this in a medium, 55 ohms, what are we looking for here? The temperature in this one, which is the degree Celsius. Formula which says that fundamental interval minus lower fixed point. Sorry, this is 10. Okay. Okay, sorry for that. Now, fundamental interval minus what? Lower fixed point, which is equals divided by upper fixed point over lower fixed point. So let's go. We are going to say 55 minus 10 divided by what? 70 minus 10. Right? Now this is equals to x minus 0 divided by what? 100 minus 0. Is that clear? Now by the time we subtract, we're going to get 55 minus 10. That is what? 45 all over 70 minus 10. That would be what? 60. Now it is equals to x minus 0 is x and 100 minus 0 is 100. Now because we're looking for this x, which is the temperature, let's do cross multiply. 60x is equals to 45 times 100. All right. Do you have any question you can ask? All right, we have come to the end of today's class. Okay, so I'm going to drop an assignment in my community post. You can go to my channel and search for the assignment and copy it. Okay, I will drop assignments under Fahrenheit and Kelvin scale. So look at it and see how we can solve it. Tomorrow's class, I'm going to put on the group the time you are going to use for the class tomorrow, because tomorrow happens to be Sunday. Okay, I will see you next time in the next one. Bye for now.